Okay, so the processed food industry has certainly advanced and evolved over the past 50 years to provide us with all of this fare, which we are now consuming. But what's interesting is with all of the different processed food that's out there for us to be able to choose from today, how many companies do you think make those? It turns out there are 10. And here they are. Okay? Kraft, Coke, Pepsi, Kellogg's, Mars, Unilever, J&J, P&G, and Nestle. Okay? They control 90% of the food distribution and marketing in this country. These 10 conglomerates. And to be honest with you, they all do the exact same things. So that's very interesting. So basically, our food has been uniformly changed over the past 50 years. A very good experiment in terms of before and after. So let's talk about that. Okay? So here's what processed food is. Number one, it has to be mass-produced, okay, on a big scale. You know, we're not talking about individual chefs here. We're talking about, you know, conglomerates. Anybody ever been to a food processing plant? You have, huh? What was it like? It's a plant. Are there any windows? There are no windows. Why is that? Why are there no windows in a food processing plant? Because they don't want you to see what's going on in there. Because if you did, you wouldn't eat it. Okay, truly. You can't believe what's going on there. There is not one piece of machinery that is recognizable that would be in a normal kitchen. Nothing. It has to be consistent batch to batch, because not just batch to batch, but in fact location to location, because they're making it in different places at different times. Okay? It has to be consistent country to country, for obvious reasons like McDonald's, right? You know, because after all, you know, it's McDonald's. It carries the brand. It's got to, you know, convey a certain taste. Specialized ingredients from specialized companies. We're not talking about, you know, just food here. We're talking about all sorts of additives, and we're talking about all sorts of other things that you add to the food in order to make those things consistent from country to country. Virtual every macronutrient is pre-frozen. The only thing that's not pre-frozen are the spices. Everything comes from a freezer. Fascinating, really. Okay? And that means that the fiber had to be removed, because what happens when you freeze fiber? You get mush. Go home, take an orange, put it in your freezer overnight, take it out the next day, put it on the counter, thaw it, try to eat it, see what you get. What do? You get mush, because the ice crystals macerate the cell wall of the plant with the orange, okay, and allow the water to rush in and turns it into mush. But of course, food industry knows that. So what do? They squeeze it and freeze it, lasts forever. Goes from being a food to being a commodity. That's the definition of a commodity, storable food. And you can buy and sell commodities on a commodities exchange. You can't buy and sell food on a food exchange, but you can with commodities. So this works for people trying to make money. Okay? It has to stay emulsified. What does that mean? Everybody know what emulsifiers are? So these are chemicals, they're detergents, really, that help bring fat and water together. All right? That's why you add detergents to the washing machine, is so that you can get the soaps to the stain. Otherwise, you couldn't do that. So what happens if those emulsifiers are working inside your intestine? What do you think happens? It actually strips off the mucus layer of the epithelial cells inside your intestine. And there are actually studies now, in animals at least, we don't have human studies, that say that you can actually show closer apposition of the food to the cells because the mucus layer has been damaged and has actually been lost in some cases. And that may be part of the problem of food allergy and irritable bowel syndrome and several of the other food-related diseases that we know about today. Although that's not known for sure yet, but there was a paper in Nature just 3 weeks ago that posed that, at least in animals. Okay? And again, it has to have very long shelf life or freezer life. Everybody knows the 10-year-old Twinkie, right? Right? It's got to last forever. Right? And that's, again, for depreciation. So let's list what processed food is, how it's different from real food. Everybody got it? So, not enough what? Not enough fiber, because you have to take the fiber out in order to freeze it. Not enough omega-3 fatty acids, which you find in wild fish, not farmed fish, because the fish don't make the omega-3s. What makes the omega-3s? The algae make the omega-3s. The fish eat the algae, we eat the fish. So, if you're consuming farmed fish, which is processed food, you might as well be eating a steak. All right, everybody got that? Very important you understand that. So, you have to know where your fish comes from. Well, of course, how do you find out? Sometimes not so easy. Okay. Micronutrients, okay? Not enough micronutrients, because the micronutrients travel with the fiber fraction. So when you remove the fiber, you remove a lot of the micronutrients. So most of the processed food is deficient in micronutrients that we need in order to be able to metabolize food properly. And then there's a whole bunch of things that are too much. Too much trans fats. Now, we know that trans fats are bad. This stuff is consumable poison. So much so that the Food and Drug Administration finally, after 25 years, finally on November 7th, 2013, agreed that trans fats were not generally recognized as safe. And so they will be disappearing from our food supply. Hooray. Took 25 years. Okay? What else? Branched chain amino acids, leucine, isoleucine, valine. These are 3 amino acids that you have to eat, you can't make, and levels of these in your blood correlate with metabolic syndrome, all the cardiovascular, diabetes diseases, the non-communicable diseases, all the chronic diseases that we know are all on the rise. And levels of these amino acids correlate with those in humans, and they are higher in corn-fed anything, which of course is processed food. Corn-fed beef, corn-fed chicken, corn-fed fish, which is farm fish. Okay? Omega-6 fatty acids. So what are omega-6s? Those are pro-inflammatory. Now you need omega-6s, you need omega-3s, you need both, but you need them in the right ratio, and omega-6s is what you find in seed oils, like corn oil, soybean oil. And these are pro-inflammatory. Now you need inflammation because you need to be able to knock out bacteria, you need to be able to mount an immune response when you're sick and have a virus, etc. But you don't need it all the time. So we're supposed to have an omega-6 to omega-3 ratio of about 1 to 1, we're told. We right now have an omega-6 to omega-3 ratio of about 25 or 30 to 1. So the question is that pro-inflammatory or not? All these different additives, and I don't want to get into all the different additives because we could go off for 10 hours on all the different additives, and that would just, there's not enough videotape in the camera for that. Emulsifiers, like I mentioned, okay, the ones that you may have heard of are called polysorbate 80 and carboxymethylcellulose. Those are the emulsifiers that are typically used. Too much salt, right? Everybody knows about salt. So salt's very complicated. There are some people who are exquisitely salt sensitive, and they need a reduction in their salt content. And there are some people who aren't as salt sensitive, and it's not as important. Now, as a doctor, I care about everybody, and we are triple over our salt limit. So I'm for reducing salt, but when you look at the data, it's complicated as to who benefits and who doesn't. But nonetheless, it's still a good thing to reduce salt. And then the big one, sugar. Okay? And that's what we're going to talk mostly about today, because the food industry uses sugar like you use salt. Okay? They hype up virtually every food to make it more palatable, and they do it with sugar. Why? Because there are 5 taste buds on your tongue. Okay? There's sweet, of course. There's salty. There's sour. There's umami. Everybody knows what that is. That's like roast beef or soy sauce. And then there's bitter. So here are examples of each of those. So sugar hides salty. That's like Chex Mix or honey roasted peanuts. It hides sour, like the German wines, you know, I mean, nobody would drink that stuff except that they add a little bit of Suss Reserve back because there's so much citric acid in the German wines because they don't get any sun, okay, that you have to cut the acidity, and you do it with sugar. It's the same reason why you add a little sugar to your salad dressing when you make balsamic vinegar and oil, because it cuts the sourness or a little bit. How about, and lemonade, of course. It cuts umami, like sweet and sour pork. You know, that's half soy sauce. You wouldn't touch that, except you add a little sugar. You can't even tell that there was any soy sauce in there. And then finally, it cuts bitter, like milk chocolate, right? Okay. So, why? Here's why. Because there are no foodstuffs in nature that are both sweet and acutely poisonous. None. It was the signal to our ancestors that any given food that they found in nature was safe to eat and wouldn't make them keel over and die. Liking sweet is ingrained into our DNA. We love this stuff. We will go out of our way for this stuff. It is completely vestigial from a metabolic standpoint. It gives us no benefit in terms of anything but as an energy source. There is no biochemical reaction in the body that requires dietary sugar. Yet, we love it anyway. Some calories cause disease more than others because different calories are metabolized differently in the body. It's called nutritional biochemistry. And you want to know the kicker of all this? I learned this in college. I majored in nutritional biochemistry at MIT. In 1975, I knew this. And then I went to medical school. And they beat it out of me. And I forgot all this. Because that wasn't what we learned in medical school. We learned a calorie was a calorie. We learned obesity was the problem. We learned that if you eat too much and you exercise too little, you gain weight. And we learned that that fat that you gained caused all of the metabolic disturbances that we now see. And then I started doing my own research in 1995. And you know what? By 2005, I was absolutely convinced a calorie was not a calorie. And I came to the realization, wait a second, I started having night sweats. I started waking up in the middle of the night with like post-traumatic stress disorder. Because like, I knew this. And I had lost it. And I got it back. Maybe that's why I'm so passionate about it now, is because medical education does not discuss this. Because they don't get it. They don't understand it. And if you kick that out from under, what happens to your understanding of physiology, of science, of nutrition, of biochemistry, and of health? Basically, we're kicking it out from under. And people don't want it kicked out. And so there's this big fight, this big tension. And that's why we're having this discussion now. But a calorie is not a calorie. Now, how do I know that? Because we have the data. So here is a study from Europe called the EPIC Interact study. And what they did was they asked, do sugared sweetened beverages cause diabetes? So if you look at the red box at the bottom, what they did was it's called the adjusted model. They looked at every sugared beverage per day, adjusted for its calories and adjusted for its effects on obesity by BMI. And they showed that every sugar beverage increases your risk for diabetes by 29%. And we're not consuming one sugar beverage, we're consuming 2.5 on average. So take that up to 68%. Okay. We did this study, which didn't look at consumption, we looked at availability within countries. What we did was we took the Food and Agriculture Organization statistics database, which listed line item, country by country for the entire decade, 2000 to 2010. Total calories, fruits excluding wine, meats, cereals, fiber-containing foods, oils, sugar crops, and sweeteners. Line by line, item by item, for the whole decade, country by country. We then regressed that with the International Diabetes Federation statistics database for diabetes prevalence, country by country for the same period. And then we regressed that with the World Bank Gross National Income database, which controls for poverty, urbanization, aging, physical activity, and obesity, all the confounders. Remember, you have to adjust for the confounders when you do science, right? And we asked the question, what about the world's diet predicts diabetes change country by country over the decade? And the answer, only sugar. Nothing else. Nothing else even came close. For every 150 calories extra any country ate, diabetes prevalence went up a total of 0.1%. Nada. But if those 150 calories happened to be a can of soda instead, diabetes prevalence went up 11-fold, 1.1%. And again, we're not drinking one soda, they were drinking 2.5. This study actually meets the criteria which were set up by Austin Bradford Hill back in the 60s to implicate tobacco and lung cancer. That is, dose, more sugar, more diabetes. Duration, longer sugar exposure, more diabetes. Directionality, countries where sugar went up, more diabetes. Countries where sugar went down, and there were a few, less diabetes. And most importantly, for causation, you have to show precedence. 3 years. Whenever sugar changed, diabetes changed in the same direction 3 years later. That's causation. Same level of proof we have today for tobacco and lung cancer. Okay? Okay. Why? Here's why. Because sugar drives fat accumulation in the liver. That's why. Because when you put fat in your liver, then your pancreas has to make more insulin, and that burns out the pancreas and causes diabetes. And you can see from this study from my colleague Jean-Marc Schwartz, that was just in JCNM like 3 weeks ago. You can see that you can do the control period and then the sugar, or you can do the sugar period, then the control. Bottom line, it doesn't matter. The amount of liver fat went up 38% for the same number of calories over a 2-week period. And that drives insulin resistance, and that drives increased pancreatic insulin release, which then drives chronic metabolic disease. And we just had an abstract at the Endocrine Society just a month ago, and you can read it here. Restricting fructose in obese Latino and African American children reduces fat accumulation in the liver. 30% reduction on the same number of calories in 10 days, which also improved their insulin resistance and every other aspect of their metabolic health without changing weight. It didn't change their subcutaneous or big butt fat. It changed their visceral fat, and it absolutely lowered their liver fat. Same number of calories, because a calorie is not a calorie. And this is for heart disease death. This was published last year by Yang et al. From Harvard School of Public Health and the CDC. So what you're looking at here is a histogram of percent of calories consumed as added sugar over a 2-decade period. And the median of this histogram is 18%. Can you believe that? Half the country consumed more than 18% of their calories as added sugar. That's insane. It's supposed to be 4%. It was at 18%. Okay? Now that red line in the center is the hazard risk ratio for heart disease death. And the inflection point is at 15%. Median's 18%, inflection point 15%. So what does that mean? It means that more than half of the United States has an increased risk of heart disease death due to their added sugar consumption. Controlling for obesity, controlling for calories, just because of the added sugar. Because it's not about the calories, and it's not about the obesity. Alcohol is not dangerous because it's calories. Alcohol is not dangerous because it causes obesity. Alcohol is dangerous because it's alcohol. Sugar's the same thing. It's dangerous because it's sugar, because of its unique stereochemistry and because of what it does and because of how the liver metabolizes it. Because it's not necessary, because it's not really a nutrient. It's an energy source, it's not a nutrient. In fact, we have causation for these 4 diseases, and these 4 diseases will be on that warning label if the California State Legislature passes the motion. Diabetes, heart disease, fatty liver disease, and tooth decay. We have causation for every single one of those. The ones we only have correlation for today, so we don't discuss them yet, is cancer and dementia. But I'm really interested in both of those. And I just met with Stan Prusner, the Nobel Prize winner up at UCSF, about whether or not sugar could cause dementia and how we might be able to actually look at that question going forward in the next couple of years.